Hello, students. Welcome to the session. Today, we'll be discussing about the locus. What is exactly locus and how to solve the question, etc. We'll be discussing in today's class. So, first of all, what is meant by locus and how we are using this word locus? See, locus is nothing but like set of points set of points. Okay. So what exactly this means? You take a straight line like x plus y is equal to 2. Or you take a line x is equal to 5. Or you take a line y is equal to 2. So what is this one? Here x plus y is equal to 2 is a straight line. All the points where sum of the ordinate and abscissa is equal to 2. So you have infinite many points. Instead of writing every point like 2 comma 0, 0 comma 2, 1 comma 1, etc. etc. You can write many. So instead of writing all these, we'll write x plus y is equal to and this one. So when you represent in the coordinate system and express this x plus y is equal to 2. So entire this path is the locus. X is equal to 2. Maybe line is like this. Y is equal to line is like this. So locus is nothing but set of points which are satisfying given condition. Given condition. That could be a linear relation, that could be something else, whatever. Accordingly, you need to apply that condition to get the relation between x and y. So, in other words, locus is nothing but set relation between x and y. So, with that relation, whatever you are putting on the graph paper or in the two-dimensional geometry, that path is locus. So, now here I'll be discussing about another thing. It's related to the circle. What are we talking about here? We are talking about locus of point which is at a constant distance or from a fixed point alpha comma beta. That is called a circle. Okay. So what exactly that? If this is a point alpha comma beta, now from here, how many points from here you'll be having R units? So if I say, for example, if this is 1 point, maybe here 1 point, maybe this side here 1 point, maybe this side is 1 point, here 1 point, like this one. So all these points are how many units away from the given point alpha comma beta? R units. So if I take one of these point Px comma y and this given point is C alpha comma beta, so it is Cp is equal to R units, or you can express it as Cp square is equal to R square. So we all knew the distance between 2 points formula. With the help of that, you can write x minus alpha whole square plus y minus beta whole square is equal to R square. This is the equation of the circle. Or in locus, what you need to say? These are locus of points which are R units away from alpha comma beta. Okay. Now here instead of alpha comma beta, if you have origin, set of points which are R units away from the origin. If this is alpha comma beta, sorry 0 comma 0, and this point is Px comma y. So what is OP is equal R unit. The locus is going to be x square plus y square is equal to R square. Okay. Now, next point is locus of third vertex of a right angle triangle whose ends are whose ends of the hypotenuse are x1, y1 and x2, y2 is a circle. The locus is a circle. How that is coming as a locus? So you have this one as a right angle triangle. This is a point x1, y1 and this is the point x2, y2. So this is the point P x comma y. Now this is right angle. What is the locus of this? So if you recollect your plane geometry earlier years, angle in semicircle will be right angle. So if this is the hypotenuse and this angle is 90 degrees, the locus of P is going to be circle because wherever you take any point on this one, you are going to get 90 degrees. Now, how can we prove this? Simple. Slope of AP into slope of BP is equals to -1. So, slope of AP y minus y1 by x minus x1 into slope of BP is y minus y2 by x minus x2 is equal to -1. So from your simplification you'll get. Not only this one, even you can go for Pythagoras theorem also. What is that one? AP square plus BP square is equal to AB square also. And this formula is very important for us, not only here in our later part of the course, circles, where this is the equation of the circle whose end points of the diameter are x1, y1 and x2, y2. There also we use this property. Okay, please have a look at this. Moving to the next one. This is related to ellipse. So before moving into this, let me brief you about a small point, triangular inequality. See, if you have a triangle like whose vertices are A, B, C, or let me take it as A, P, A, B, P. So here, sum of two sides AP plus BP is always greater than or equal to AB. AP plus BP always greater than or equal to AB. So that's why if PA plus PB is equal to K greater than AB one case and K is equal to AB one case. Now K less than AB, we are saying it is the empty set. So no chance of getting AP plus BP less than AB. There is no point in the plane which satisfying AP plus BP less than AB. So here let me take like this, AP plus BP is equal to K, where K is greater than AB. K is greater than AB. So what is this locus? So here A, here B. So equal to P is equal to K. AP plus BP is equal to AB. Then point will be somewhere. But if it is greater than, P will be somewhere here. So this is, you are going to get that locus as the ellipse. The locus as the ellipse. Again, this definition also for us very important for the chapter ellipse. the chapter ellipse. So the distance between AB as equal to 2AE and AP plus PB is equal to 2A, and we derive the midpoint of AB as the center of the ellipse. Whereas AP plus BP is equals to AB. In that case, the locus of P must and should be on the line AB. It is somewhere here between. So it should be exactly on the line segment. It is a point on the line segment. And as I told you already, K is less than AB, locus is empty set. No such point possible. And this definition is very much needed for us to derive the ellipse equation, and to this concept is very much needed for MSET as well as any national level exams. Okay, moving to the next point, same extension to the previous thing, triangular inequality only. Okay, so sum of two sides greater than the third side. Here it is difference of two sides. Difference of two sides like AP minus BP. The difference of two sides always less than or equal to AB. Okay, and here if A is here, B is here, P is a point here, AP minus BP is equal to K, where K is greater, sorry, K is less than AB. K is less than AB. The locus will be like this for this. And BP minus AP is equal to K, the locus is going to be like this for this. So combination of this one, this. It is called hyperbola. And again, this AB is equals to 2AE, where E is the eccentricity, and modulus of AP minus BP is equal to 2A. Okay, and if K is equal to AB, so you take this line, A is here, B is here. Any point you take here, AP is here, AP minus BP will be equal to AB. Or if I take P here, BP minus AP is equal to 2A here. So where K is equal to AB, it is a union of two rays. One ray is this side and another ray is this side. And K greater than AB, we don't have any solution set. Okay. So here again, to take why these two is happening and the last one is not happening, because of the triangular inequality. Moving to the next one. A and B are two given points. The locus of P, such that area of the triangle PAB is K units, is pair of parallel lines. The locus is pair of parallel lines. What is this? Means if I want to talk about area of the triangle, here AB, if this length is base A units, okay, somewhere here P is there, whose height is H, then the area of the triangle APB will be of AH. is equal to delta K units. So here, if this is AB, for example, there is a line parallel to this which is having the height of H units, okay, which is height of H units, okay. So point is here, this area or area of this triangle or area of this triangle or anything area of this triangle, all these are same because base of the triangle is fixed and height is also fixed. So area. So what happened? This P is your height is equal to 2K by A units, where A is fixed and K is also fixed. So now the point P is exactly A and B. It will be point is any line, any point on this particular line which is parallel to AB. Either this side is possible or this side is possible. So what happened? Then the locus is pair of parallel lines. Okay. So here AB is fixed. You take this P here, this area of triangle. P is here. Area of this triangle remains same. Or if P is here, this triangle area is also similar. So when A and B are two fixed points are given and fixed area is given, the locus of P is going to be set of parallel lines. Okay. And moving to the second point of this, let me clean the board once. A and B are two given points. Locus of P such that PA by PB is equal to K is by 1. If K is not equal to 1, locus is circle. K is equal to 1, locus is perpendicular bisector. Here A and here B, two fixed points. Locus of point P, which is equidistant from these two. P is equidistant. This length is equal to this length. So the locus of P is going to be a perpendicular bisector. Why we are calling perpendicular bisector? Means it is bisecting perpendicularly. This length is equal to this length. So here AP by BP is equal to 1. So that's why 1 is to 1, that is a perpendicular bisector. Now, if in case AP by BP is equal to K by 1, on simplification, you will be getting AP square is equal to K square into BP square. So it will be x minus, let us say x a as x1 y1 plus y minus y1 whole square is equal to k square into x minus x2 whole square plus y minus y2 whole square. On simplification, you are going to get 1 minus k square into this is x square plus y square plus sum 2 alpha x plus 2 beta y plus c is equal to 0. Whatever this I am least bothered about. But here what happened? X square coefficient is equal to y square coefficient. There is no xy coefficient. So it will represent a circle. Okay? It will represent a circle. So this is how you are going to get. And when the k is known, after simplifying, you can find the center, you can find the radius of the circle, etc. Okay? So here this particular concept not only useful here, this concept is useful for in the complex numbers also. So make a note of this. What is that? AP by BP is equal to K. and k is equal to 1, it will be a straight line and perpendicular bisector, and k is not equal to 1, it is going to represent a circle. Okay, moving to the next one is ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. This is known as the general second degree equation, and here important thing, delta is equal to abc plus 2fgh minus af square minus bg square minus ch square. So this second degree equation may represent pair of lines or parabola or ellipse or hyperbola. Look at here, this is pair of lines, which is the uh, intermediate first year syllabus, and this is parabola, ellipse and hyperbola intermediate second year. So what is delta? Delta is ABC plus 2FGH minus AF square minus BG square minus CH square. So when the general second degree equation is given, immediately you need to find delta, and based on the delta, you need to decide whether it is a pair of lines or conic section. This is called the conic section. Okay. So what is the first thing we need to do is h square is equal to AB, delta is equal to 0. Pair of parallel lines are pair of coincident lines, and delta is not equal to 0, it's a parabola. H square less than AB. If it is a homogeneous second degree equation, means if this portion is not there, only ax square plus 2hxy plus by square is there, and h square is less than ab, then you'll have only a single point, that is origin. But if this is h square is less than ab and you have some x and y terms also, then it is pair of imaginary lines. Whereas if delta is not equal 0, it will be represents ellipse. H square greater than AB, pair of intersecting lines are hyper. H square greater than AB and A plus B, perpendicular lines are rectangular hyperbola. Along with this one, you need to know this one also. That is, if A is equal to B, if A is equal to B and H is equal to 0, A is equal to B and H is equal to 0, you can represent this one as, you can represent this one as a circle. So standard form of this circle is always x square plus y square plus 2gx plus 2fy plus c is equal to 0. So when the general second degree equation is given to us, you need to go for primarily delta. To find the delta, we also have the other way of solving. Instead of doing this one, even you can determine with the determinant also we can do A, B, C, F, F, G, G, H, H. This value has to be equal to 0 to represent pair of lines, and if it is not equal to 0, it will not represent a pair of lines, but it will represent conic, and particularly that one either parabola or ellipse or hyperbola. In the hyperbola, special case is rectangular hyperbola. Okay, right. Moving to the next one. So when the curve is given, how can we translate into other one? Or how can we say whether it is a symmetric about x-axis, symmetric about y-axis, or origin? So if any curve is symmetric about x-axis, means f of x comma y is equal to 0. If this curve is symmetric about x-axis, so where is the x-axis? This is the x-axis. So if the curve is like this, anything symmetric to this one with respect to x-axis will be like this. So what happens? For example, here x comma y is a point. Its image with respect to this one is x comma minus 1. So that's why if f of x comma minus y is equal to f of x comma y, the curve is symmetric about x-axis. Similarly, if the curve is symmetric about y-axis, look at here. So if this is x comma y, this is minus x comma y. X comma y here, and this is minus x comma y. So for a point curve to be symmetric about y-axis, f of xy is equal to 0 and f of minus x comma y is equal to 0 should be remain same. And the last but not the least, if a curve is symmetric about the origin, so for every x comma y, image with respect to origin minus x comma minus y should be present here. So that what happened? It is up symmetric about origin. If f of minus x comma minus y is equal to f of x comma y. Okay. So not only this one, in this particular chapter, we also need to look at the problems that we will discuss in the coming sessions. Thank you very much. All the best. See you later.